Hello everyone, this is Bradley Sward, and in this video today is the 2022 Advent of Code Day 10 solution for part 1 of the problem otherwise known as cathode-ray tube. And so for part 1 here, we're basically kind of virtualizing, we're just creating a mini CPU here, and it only has two different operations. And so when your program starts, or I guess when your computer starts, the X value, the register is stored as a 1, and basically over time, when you no-op, you go to the next clock cycle, but you don't do anything. Otherwise, it takes 2 clock cycles to add a value into this register, and you can go plus or minus. So it's a very simple CPU. And so the question just becomes, the tricky part with this was the during a clock cycle versus after a clock cycle. And I'm still not 100% sure if I just kind of lucked my way into the answer, or, it's just one of those things where I got a solution. I'm not really going to put too much more thought into it, but just to say that at least for the solution here, like the during would be the previous clock cycle, and the after would be the current clock cycle of the value inside of there. And it doesn't make much sense if you haven't tried looking through the problem, because if you just go off of certain values in an array, it doesn't work so good. But if you look one value into the past of what it was prior to the previous clock cycle, I do get the correct answer here. So here's my code. Here's the boring stuff to get the file in here as a list of strings here, a broken up list of strings. And so essentially, presuming that the two operations are the only ones in here, you always go to the next operation without doing something, no matter what. So the no-op will automatically do that, but so will the first operation, or the first part of the operation for the add operation here. So in this case, I always add whatever was previously in my list, and then after that's said and done, then I add the value as the second part. And so if you follow that along, where over the different clock cycles, this list will maintain at the end of every clock cycle what was the value of that X register, and you can just use the index values to determine, that, like, the clock cycles, because this is clock cycle 0, and then everywhere from there on in would be after 1, after 2, after 3, after 4, and so forth and so on. And so, and again, the tricky part, at least with this, was because if you do such where you just multiply it by the X value, because you're like, oh, 20, 40, 80, whatever, or 20, 60, 100, and whatever you get, you do get a different answer than the one you're supposed to get, the 12,840. But again, it says in the actual problem to go ahead and look at what was during the clock cycle and not after the clock cycle completed. So again, for me, if I just do a subtract 1 from that to get the previous clock cycle's X value, I do get the correct answer of 12,840, which was what was expected, or at least what is my solution to part 1 of the problem. So now I'm ready to move on to part 2, but I just wanted to get this out there before I lost my momentum. So thanks for sticking it out with me as always. Questions or comments, of course, love to hear them. Thanks for everybody. See you guys in another.